Today we deal with the chapter on chapter in mathematics that is called calculus. Now it is a very important branch of mathematics. So it is used in all branches of science, all branches of knowledge. Like it is used in physical sciences like engineering. That is what applied mathematics like engineering and higher physical chemistry and physics. And it is also used in social sciences like sociology, economics, and commerce. It is also used in the biological sciences like higher botany and medicine or hard science. So we shall take up to understand. Now this is developed by two people, one by Newton and Leibniz. Newton is from UK and then Leibniz is from France. And these two people developed the same branch of mathematics. It is a rare coincidence that from the same continent in two different countries, two people without knowing each other in the same period develop the same branch of mathematics. To understand this particular thing, we have to have a pre-knowledge like in limits. So we shall enunciate some formulae which you have already studied, and those things I will list them and which you are going to use while developing the one branch of calculus once again, that is differentiation. The things that we are using, that is formula in limits, I list them here. Number one, say limit n tending to 0, 1 by n tends to infinity. Number two, limit n tending to infinity, 1 by n tends to 0. Whenever infinity comes, say we should not write equal to. Number three, limit n tending to infinity, 1 plus 1 by n whole power n is equal to e. Number 4, limit n tending to 0, 1 plus n whole power 1 by n is equal to e. Number 5, limit x tending to a, x power n minus a power n, it is what n here, by x minus a is equal to n into a power n minus 1. And number 6, limit theta tending to 0, sin theta by theta is equal to 1. Number 7, limit theta tending to 0, tan theta by theta is also equal to 1. Here theta is measured in radians. Number 8, limit x tending to 0, e power x minus 1 by x is equal to 1. Number 9, limit x tending to 0, e power ax minus 1 by x is equal to a. To make it 10, limit x tending to 0, a power x minus 1 by x is equal to log a. In general, we don't write the base e, but here base e is not written, it is log a to the base e only. Now, in calculus, we take differentiation. Now, derivative of f of x with respect to 2x. See, this is what we are going to do. Newton, we are going to follow Newton's method. That is what, first derivatives and then integration, like that. Derivative means differentiation only. So now he has given 5 steps. So let us use, suppose if you want to differentiate fx with respect to x. let y is equal to fx, f of x. Let delta x be a small change in x and delta y be the corresponding change in y. So if there is a small change in x, that is what independent variable. There will be a small change in y, that is what dependent variable. So y plus delta y is equal to f of x plus delta x. Now below that you write the original function y is equal to fx. Then subtract. Therefore delta y is equal to f of x plus delta x minus fx. Limit, take limits both sides after dividing by delta x. Now we divide both sides by delta x first. So delta y by delta x is equal to f of x plus delta x minus fx. Then we divide by delta x. Now after that we have to take limits both sides. This side, left hand side, limit delta x tending to 0 and limit delta x tending to 0. If the right hand side limit exists, it is written as f dash x. So if y is equal to fx, dy by dx is equal to f dash x. With this method, we try to derive some derivatives of certain functions with respect to x. First one, differentiate x power n with respect to x from first principles. So whatever function is given, that one you write as y. Let y is equal to x power n. Say let delta x be a small change in x and delta y be the corresponding change in y. So when there is a change in that is what in right hand side in x, there will be change in y also, that is why delta y. So we write y plus delta y is equal to x plus delta x whole power n. Don't write plus delta x separately. Wherever x is there, x plus delta x. Below that, y is equal to x power n. Then subtract delta y is equal to x plus delta x whole power n minus x power n. Now same sentence, divide both sides by delta x and take limits as delta x tends to 0. Take limits as delta x tending to 0. So now, first of all, you divide delta y by delta x. By delta x, you divide x plus delta x whole power n minus x power n by delta x. Now at this stage, write the limits. Limit delta x tending to 0. Here also limit delta x tending to 0.